Welcome to this V-Ray feature short demonstration. In this video, we'll take a closer look at the image sampling in V-Ray, the process of how the color of each individual pixel of the image is determined, as well as how we can control the image sampling process. In a final rendered image, each pixel can have only one color. However, within a single pixel there might be multiple colors from various objects or parts of a detailed texture. The differences between those colors might be very subtle. In such a case, V-Ray needs to determine the most appropriate color for that particular pixel in a way that looks as realistic as possible. To get the job done, V-Ray samples colors from different parts of the pixel and the neighboring pixels around it. While performing the image sampling, V-Ray shoots two general categories of rays, primary and secondary. Primary rays are shot from the camera and help with anti-aliasing, cleaning up noise in motion blur and depth of field. Also in high-frequency details such as fine bump, high-contrast textures, fine displacement, hair and fur, and many more. When a primary ray hits an object, it spawns a number of secondary rays, which in turn help determine all the shading effects, soft shadows, and global illumination. V-Ray analyzes the whole scene and its contents, and based on smart and optimized algorithms decides which parts of the image need more sampling and which parts need less. Since V-Ray version 3.3, it's no longer recommended to use the legacy workflow where control is allowed over the number of rays V-Ray shoots for each individual shader or light. Instead, it's recommended to let V-Ray adjust itself and give you optimized performance. In this scene, we have an exterior environment containing a grass field and a cannon. Let's open up the render settings, and under the V-Ray tab, we can choose the type of image sampler. There are a couple types to choose from, bucket and progressive. Both types would eventually produce the same result, but the way of accomplishing that differs. The bucket type renders the image in rectangular regions called buckets. The progressive type, on the other hand, works on the entire image at once and progressively refines it. Both sampler types have advantages in certain situations. For example, the progressive image sampler is excellent in providing a quick feedback on the entire image. If you don't know how long the rendering will take, the progressive sampler type would keep on refining the entire image until the noise threshold value is met or until you manually stop the rendering. This makes it a very good choice for look development and also for final renders. Another situation where you find the progressive type very useful is when rendering animation previews. You can limit the rendering of each frame by time constraint. Also, the interactive production rendering, the IPR, is using the progressive image sampling. The bucket image sampler type has several advantages of its own. For instance, the bucket sampler has better CPU utilization since the image doesn't need to be displayed all the time. That makes it great for rendering final images and animation. The distributed rendering, or DR, is more efficient while using the bucket mode. When it comes to rendering large resolution images, the bucket image sampler uses less RAM as it has the ability to write directly to the disk. Lastly, some features like deep rendering and cryptomatte are currently only supported in bucket mode. Let's take a look at each image sampler type separately. Let's choose the progressive type. You can specify a condition which once met would stop the rendering process, or you can stop the rendering manually once you're happy with the result. You can specify the render time in minutes, especially useful option when rendering animation previews. Or you can specify the noise threshold amount, which controls the noise level in the image. Let's leave everything with the default values and hit the render button. As you can see, the entire image gets progressively better. You can stop the rendering at any time, make some changes to the scene and re-render. Let's stop the rendering and make a change to the lighting of the scene. Using the progressive image sampler, we can quickly reiterate adjusting the lighting or the materials, for example. Once ready for the final render, you can go ahead and use the progressive image sampler for the final render, or switch to the bucket sampler type. The way you control the quality of the render using the bucket type is by adjusting the min and max subdivs and the noise threshold. The default values of 1 and 24 for the min and max subdivs is enough for most situations. In specific cases such as depth of field on black background or very strong motion blur, for example, the min and max subdivs values might need to be increased. Let's render a region using a value of 0.1 for the noise threshold and examine the quality. Apparently a value of 0.1 produces quite noisy result. You can lower the noise threshold further to clear the noise. A value of 0.005 would produce a very clean result in most cases. Lower noise threshold values give you cleaner image but require a longer amount of time to render. You could use a noise threshold value of 0.01 or even 0.03 and use the V-Ray denoiser afterwards to additionally clean some of the noise in the image. In this video we went over the V-Ray image sampling, the theory behind coloring of each pixel of the image together with settings and workflows for specific situations. I hope you found this video useful and helpful. Please give us your feedback, comment or share it. If you'd like to follow along this tutorial, please download the scene from the link provided in the video's description. Make sure you check out more of the V-Ray feature videos and be on the lookout for new ones. Thank you for watching.